Hi, and welcome to the video where we take a look at car or vehicle and pedestrian or people detection, okay? So stay tuned when we move into the IPython notebook to load our video. Alright, so now let's load code number 14, car and people detection. So let's bring this up, and here we go. So now here's a note for some reason if your video playback, because what we're doing here, we're loading previously saved MPEG videos, or AVI videos I should say, that are here, and we're using FFmpeg to load this. So sometimes FFmpeg needs to be installed separately or found in one of these OpenCV folders here and dragged to a different folder. Sometimes it works out of the box, depends on how updated your versions are. So these are just some notes that will help you, just in case these notes were developed for older versions of OpenCV. You probably just need to remember, this all depends on the version number. There will be a version 420_64.dll. So you can just look at that, and if you have an error where it doesn't load, you can just use this fix. So it's quite a simple fix. Just take a note and if you need to do it. So now let's look at people or pedestrian detection. So what we're going to do, we're going to load a HAR Cascade classifier called HAR Cascade Full Body. This detects full bodies of people, so people walking, typically like pedestrians, will be easily identified using this classifier. And what we're doing here, we're loading this video file here. So we're using the CV2 video capture function and pointing to the file directory or the location of that video file. And what we're doing, resizing the video, making it half its size so we can increase the frame rate that it's processed at. We grayscale that video, and then we load each frame from that video into our body classifier. And then we just draw a rectangular box over it, okay? And then we also have a break here where if you press 13, or basically which corresponds to the enter key, it will exit this loop, so you can stop the video before it's completed. So let's load this video, and you can see this is pretty cool. So you can see all these people walking here. It identifies them fairly accurately, not all the time, but it is pretty good. So now let's take a look at car or vehicle detection. So again, we're using exactly the same code, same format. You may have noticed that there is a sleep function here. Sometimes this is necessary when we load videos, sometimes it's not. You don't have to put it in, it just was a fix I noticed when older versions of OpenCV on some systems, you needed it. However, it's not really needed in most cases with the latest versions. So what we're doing, we're pointing it to the cars.avi file. We're loading a HAR Cascade underscore car. That's a HAR Cascade classifier that's trained to detect cars. And again, we're drawing frames over it and grayscaling it and passing it to our detector or car classifier detector. So let's test this out and see how it works. Now you can see it works fairly well, but it misses a lot of the vehicles. There's a lot of cars being missed. So you may want to increase the sensitivity of the parameters in the detector. So that can be a homework lesson for you guys, and you can try it out. Now you can see, generally though, HAR Cascade classifiers aren't that great, which leaves room for a lot of improvement. And that is how we have a lot of advanced, basically I would say deep learning object detectors. Things like YOLO or SSD or RCNNs or faster RCNNs are all quite good and quite better at these tasks than HAR Cascade classifiers. HAR Cascade classifiers had a place when it was used for facial detection, and it worked quite well. However, in these more advanced cases, I would say we will need deep learning methods like the ones I just listed, which we will see later on in this course, okay? So just to summarize what we've learned in this video, this was a simple video. We just used another two HAR Cascade classifiers to do car and people detection. So you've got exposed to a lot of HAR Cascade classifiers, which are good, but as you can see in our last lesson, they leave a lot of room for improvement, which we'll actually use more advanced classifiers later on in this course. So now let's move on to section 4, where we take a look at machine learning in computer vision. Now, just before I move on to this topic, I want to speak a bit about machine learning. Machine learning brings a whole host of advanced or more accurate abilities to computer vision. So I hope you're excited for this. You'll get to see a lot better image classifiers, image detectors, or object detectors, I should say. So stay tuned for these videos in section 4 and 5 and 6, and you'll start using Keras and TensorFlow to do some pretty cool things. Thank you.